Welcome to everyone to the Symposium on Living Sensor Monitoring Pollution in the Environment. This important event is organized by the Inter-Islamic Network on Oceanography in collaboration with several leading universities from around the world. We are delighted to bring together a diverse group of experts, researchers, and practitioners who are at the forefront of innovation in environmental monitoring. You know, our planet is more critical than ever. Innovative approaches to environmental monitoring are essential. Today, we gather to explore how marine organisms are being harnessed as bioindicators and biosensors to detect and monitor pollution. The concept of living sensors is a fascinating intersection of biology, technology, and marine science. These biological systems offers us real-time, sensitive, and often cost-effective methods to assess impact of pollutions. They can reveal the shift in ecosystems long before traditional methods might, providing an early warning system that can guide us solving environmental damage. Through this symposium, we will explore the latest research and technological advances in the field of marine sciences. Our distinguished speakers will present their work on the various applications of living sensors. We will also discuss the challenges and opportunities of integrating these biological tools into broader environmental monitoring frameworks. I am really excited for the discussions that will take place today, for the insights that will emerge as collectively explore the potential of living sensors. To officially start our symposium, it is my great honor to invite the president of Inter-Islamic Network on Oceanography, Professor Shermin Açıkçınar, to deliver an opening speech. Please join me in welcoming Professor Shermin Açıkçınar. Professor Shermin Açıkçınar, the floor is yours.
Thank you. Dear scientists and participants, it's my pleasure to welcome all the participants today for Marine Sciences Symposium series that is one of the important activities of the Inter-Islamic Network on Oceanography. I also welcome distinguished speakers from Malaysia, Indonesia, and Pakistan, and they come here to share their knowledge and experiences for monitoring pollution in the environment. Water is a primary resource for the presence of life on Earth. Water quality is one of the main challenges that societies will face during the 21st century, threatening human health, limiting food production, reducing ecosystem functions, and hindering economic growth. During the last decades, water quality has been negatively influenced by a continuously increasing population, rapid industrialization, climate change, increasing urbanization, and careless utilization of natural resources. Persistent organic pollutants are organic compounds of anthropogenic origin that resist photolytic, biological, or chemical degradation, leading to their bioaccumulation in the food chain. Owing to their toxic characteristics, they can pose a threat to humans and the environment. In recent years, therefore, the international community has called for urgent global action to reduce and eliminate the release of persistent organic pollutants and to identify their possible risk to human health and the environment. Monitoring and characterizing anthropogenic disturbances and their effects on species are essential for a robust assessment of the health of the ecosystem. In order to evaluate the impact of such pollutants on the environmental quality, it has thus become highly pertinent to carry out a rapid assessment of their deleterious effects on the ecosystem. I believe that such networking activities will positively affect research opportunities and effective collaboration in the field of marine sciences among Islamic countries. I would like to thank the following institutions for their contribution to the realization of this event. COMSTECH, the Organization of Islamic Cooperation's Standing Committee on Scientific and Technological Cooperation. Dokuz Eylül University, Türkiye. Malezya Terengganu University, Malaysia. Bragjava University, Indonesia. Punjab University, Pakistan. INOC continues its activities by providing enriched trainings and supporting the research and development ecosystem in the field of marine sciences. You can check the INOC webpage and social media accounts to join the INOC network and get detailed information about research, education, and collaboration opportunities. I wish you a very productive event with exciting and increasing discussions and exchange of knowledge so that together we can anticipate a future of groundbreaking knowledge and research for marine sciences. I encourage all participants to actively engage in the discussions, ask questions, and share your perspectives. It's an opportunity for us to learn from one another, to build networks, and to identify areas where our institutions can work together to enhance the quality of marine science. Thank you for being here with us today.
I would like to thank President of Inter-Islamic Network on Oceanography for opening speech. We can continue to our symposium. Before listening our distinguished speakers, I would like to inform you that you can ask your questions to speakers, of course, but we are waiting for your questions. You need to write them to the Zoom chat box, and we will collect your all questions at the Zoom chat box, and at the end of all 4 presentations, we will ask them directly to the speakers. And of course, speakers will have also opportunity to read them at the Zoom chat box, and at the end of presentations, they will have enough time for answering your questions. So we can start with the first speakers, but before his presentation, I would like to give you information about our first speakers, who is Dr. Ong Meng Chuan from Malaysia, and I would like to give you some information about his academic background. So, Dr. Ong Meng Chuan is an associate professor in the Marine Science program at the Faculty of Science and Marine Environment, University of Malaysia, Terengganu. He holds a doctoral degree in marine pollution, specifically metals pollution, from the University of South Brittany, France. He is actively involved in teaching, research, and knowledge transfer programs for communities and school children. He is actively engaged in research and formed a research interest group, Ocean Pollution and Ecotoxicology Research Group, among UMT researchers and other institutions in Malaysia. He is currently mentoring 5 postgraduates pursuing their PhD and master degrees by research. He has successfully guided 12 postgraduate students as principal and co-supervisor until project completion and graduation. Besides, he has also supervised 80 undergraduate final year research projects as the main and co-supervisor. he has published over 100 research outputs in scientific journals, book chapters, and conference papers. He was also appointed as an associate fellow at the Institute of Oceanography and Environment, UMT. In September 2022, he was appointed as head of the Marine Science Program under the Faculty of Science and Marine Environment. So, floor is yours, Dr. Ong Meng Chon.
Okay, thank you, Prof. Bulan, for the introduction. Okay, okay, so good in Malaysia now is evening. Good evening, everyone. So today I would like to share with you all about one topic: investigating pollution through aquatic organism. Mean that we're using the organism as an indicator for pollution study. Okay, so just now Prof. Bulan already introduced me. Actually, I'm the leader of the Ocean Pollution Ecotoxicology Research Group in UMT. So here we have quite a lot of researchers in this group, and we almost cover all type of pollutant in our group study. Okay, so when we talk about pollution, actually we have a lot type of pollution actually. So we have a pharmaceutical waste, we have the organic waste, we have the oil pollution and so on. But today I will focus only on the heavy metal study. Heavy metals are pollutant. So this is my presentation outline. So we will talk about the overview of the heavy metals, and then the source of the metals, and the biomonitor of heavy metals using the organism, and how we calculate or we assess the pollution status using the organism, and what are the effect of the metals to human health, and also some finding of my research, and the current work, also what we plan to do in the future. So as an overview of heavy metals, so we know that metals actually we cannot see with our naked eyes. Okay, so they may accumulate to unnoticed to toxic level. So we don't know that the water that we drink or the water that we swim actually is clean or not until we analyze it. Okay, so if we say, okay, if the aquaculture pollution, mean that the indicator is the fish death. And then if there's a nutrient pollution, maybe there's a eutrophication, and obviously oil pollution, seems like the oil in the water and so on. And then about the debris pollution, we can see all the rubbish or the debris on the beach and so on. And sewage pollution also, we can see in our naked eyes. Okay, but metals actually we don't know until we analyze it. Okay, so as I mentioned, we don't know that the water that we drink, is it clean or no? We don't know until we have to analyze it. So metal can divide into several groups. So in here, we divide into 4 groups, okay, according to their potential, pollution potential. So normally, we as a scientist, actually, we cover the metals in very high and also very high pollution group. So mean that arsenic, cadmium, chromium, copper, and also mercury. Okay. So why metals? Metals is a serious pollutant in our natural environment due to the toxicity, persistent, and also the bioaccumulation problem. Okay, and we know that pollutant can come from natural and also anthropogenic sources. Okay, so currently anthropogenic input of metal exceed the natural input. So why we can conclude this statement? Because when we go for study in one area, several area, we found that almost all the metal actually exceed the natural level. So mean that the first conclusion that we can make actually is anthropogenic input or they exceed the natural input. So metals actually organism as like human, we require trace amount of some metals, including cobalt, copper, iron, manganese, and zinc. So we need this metal in our body system for our metabolism and so on. Okay. The excessive level of excessive metal, however, can be detrimental to the organism once they reach certain concentration. Okay, so non-essential metals of particular concern to surface water system are cadmium, chromium, mercury, lead, and also arsenic. All these metals actually we don't need in our body system. So currently, actually, metal pollution has drawn increasing attention worldwide, okay, due to the dramatic increase of anthropogenic contaminant to the ecosystem through three ways: air, water, and soil. Okay, and this pollutant actually is very serious because these chemicals are indestructible, and most of them have toxic effect on living organism when they exceed a certain concentration. No whether it's a essential metal or no essential metal. Okay. So some metal is a highly toxic and persistent and have a strong tendency to become concentrated in marine food web. So, for example, one pollutant when they go into the sea or the aquatic system, the first organism they uptake is the plankton. Okay, the primary organism, plankton, and then from there they will magnify according to the trophic level, and then normally the higher trophic organism. For example, in the ocean we have the whale, we have the dolphin, shark. Okay, so this organism might have higher concentration metals if that area is polluted. So there's two terms of the how the accumulation metals actually are processed in our body. So one is the bioaccumulation, mean that the pollutant the pollutant increase over the lifetime. So when we consume or we breathe everything, actually the metal increase in our body system. The second one is biomanipulation, mean that the pollutant that transfer according to the food web. Okay, so normally the higher level, they will have a higher concentration. Okay, so bioaccumulation increase in concentration of pollutant in an organism, in the organism itself. Biomanipulation is increase in concentration of pollutant in the food chain. Okay. So lying in the second trophic level in the aquatic ecosystem, shellfish species have been known to accumulate both essential and non-essential metal. So they are filter feeders. So they will only filter the waters. Then they can filter all the metals in the water. Okay, and many researchers has reported using mollusks, especially mussel and also oyster, as a bioindicator or biomarker for the monitoring of metal contamination of the aquatic system. So actually, the shellfish actually they can act as a vacuum cleaner of the sea, mean that they're taking in all the pollutants such as microplastic, pesticide, and other pollutant, okay, in their body system. So this is some of the shellfish that I've been used in my study. So the oyster, the blood cockles, the clam, and so on. Okay. So for me, this is this organism actually is very good indicator for to use as a bioindicator or biomonitoring agent. Okay. So why we study the metal content in the organism? Because we want to know that is it this organism or this species or this food or this seafood, is it safe to be consumed or not by human? Okay. So therefore, when we analyze the metal content in the organism, actually they can give a two finding. One is the environmental quality by using this organism as a bioindicator or biomarker. The second one is to ensure the human safety, okay, via the consumption of the shellfish or fishes. So what is the source of the metals? So river following the through urban area may bring the pollutant to the downstream as well as sediment. Okay, so mean that when they reach the downstream, they will incorporated in the mud bank cycle. Okay, and this process may result downstream as an estuary ecosystem in a higher concentration of all the pollutant. Okay, so normally when that area they have a very limited water circulation, we can determine that this area actually with higher concentration, especially in the sediment, because when there's limited water circulation, the pollutant have enough time to settle down at the sediment. Okay. So marine aquatic organisms can accumulate matter from various sources in the surrounding environment. So once the matter enter the food chain, they may accumulate to dangerous level and be harm to human health. Why to human health? Because we are the top predator. No, whether in the ocean, in the land, we are the top predator. Okay, we eat everything in the ocean actually. Okay. So this diagram, this figure shows the source of the metal in one example story. Okay, what is the source and input contaminant? So the source of the pollutant may come from the shipping activities, mariculture activities, groundwater runoff, surface runoff, okay, industrial discharge, and also the precipitation. Okay, so mean that this precipitation might bring some of the pollutant to the water system. However, when we see there's a lot of activity in this area, sometimes this area might not polluted as what we expected actually. Okay, for example, like my study in France actually, for the first hypothesis I made is this area is polluted with several types of metals, because in my study area, the Gulf of Morbihan in France, there's a lot of yachts, if not mistaken, around 3,000 yachts. So the first hypothesis I made, this area is polluted. But surprisingly, when I do all the analysis, we found that this area is not really polluted as we expected. It's slightly polluted. So because there's several factors that control the metals in the sediment. For example, the tidal exchange, the tidal current, also the type of sediment. And then from my study, we found that the tidal exchange, the tidal current, and also the mariculture activities in that area affected the level of the metal content, because that area, half of the Gulf actually is a mariculture area for the oyster. So mean that the oyster actually filtered all the pollutant before they reach the sediment. So biomonitor of the metals. So individual organisms respond differently to different source of the chemical element, for example, in solution, in sediment, or in food. Okay, therefore, it's important to use a correct organism that can reflect the element biology in available source. Okay, when we study about the water column, we have to use the correct organism. For example, like the seagrass, we can use the seagrass to represent the water column. However, if below for the sediment, maybe we can use the shellfish and so on. So before that, actually the species to be chosen as biomonitors should fulfill several criteria. Should be sedentary, because when we do the biomonitor or biomonitoring, okay, so that organism should be not moving a lot. It means that they can present that area. And also easy to identify, okay, and abundant, okay, and long-lived. This is important when we want to study for the bioaccumulation process, for example. And also always available for sampling. This is very important when we study for relate to the monsoon season, relate to the rainy season, and so on. Okay. So living organism can transfer pollutant and contaminant into, within, and out of the marine aquatic ecosystem. Okay, this organism can ingest the pollutant via water and food and inhale them as they breathe and also feeding. Okay, so there's many ways how they can uptake the metals. Okay, the choice of a suitable biomonitor need to consider the potential source of the metal to the biota. Okay, like for example, as I mentioned, the seagrass not contact with the sediment, we uptake the pollutant from the source of only. Mean that it's a good indicator for water quality. Okay. So when we have the data, we have to calculate the pollution status. So normally for organism, like my study, actually we are compare with the tolerable intake. We calculate for how much human intake that matters, okay, based on our consideration. And beside that, we also direct comparison. This is direct comparison with the the world standard. For example, like in Malaysia, we have the Malaysia food regulation. So every country, they have their own regulation, the level. And beside that, we also calculate for the pollution law index to know that is it that area is clean or polluted. So this is direct comparison. So we compare with the maximum permissible level from the other country. Like, for example, we compare with the European, the Spain, the US, the China, Hong Kong, also the Singapore. Okay. So however, actually in Malaysia, we don't have really specific sample or food category. So it's a general. So now that's why our team is looking to work together and then to create a database for the like fish, shellfish, and so on. Okay? And this is the pollution index. Normally we calculate the pollution index. We calculate the CF, the CF. So we use our sample concentration, we divide with the background value. Okay. So when we calculate the PLA value, if the PLA value less than 50, we can say that that area, there's no monitoring needed to study. However, if that value is more than 50, so we can say that this area is slightly polluted and we have to do something, we have to monitor that area. So, and then for the tolerable intake, so we calculate the PTWI value, provisional tolerable weekly intake. So this one, we calculate how much human can uptake the matters based on how much they consume that, for example, like they consume every week, consume 1 kilo of oyster. So we can calculate how much they uptake the matters in their body system. So normally I show this photo during my presentation. So actually for the shellfish, we are calculate according to the in toto. We're using the in toto, mean that we're using all the soft tissue sample, because I believe that all of us, when we eat oyster or shellfish, actually we eat all. We are not spreading into the gill, the stomach, and so on. We eat all. So mean that to make the data more accurate, actually we have to analyze all sample, combine it all. Okay, what are the effects on human health? So this is how simple one pollutant can uptake by human. So once they release to the water, they will uptake by the fish, uptake by plankton, plankton by the fish, and then fish to human. Okay, this is how very simple way all the pollutant that we throw around to the ocean, to the aquatic, actually they pass back to us actually. Okay. So we cannot say that, okay, in Antarctica or Arctic, there's no metal pollution. Okay. But we know that when one pollutant enter the aquatic environment or the ocean, actually they are mobile, mean that there are no geographical boundary. Okay. So no rather that where is the location or so, for example, like in Antarctica actually. So that pollutant also might reach the Antarctica with the water current or and so on. Okay. So every organism accumulate pollutant during its lifetime. Okay. And once eaten, its pollutant are transferred to the predator. This is a biomagnification process. Okay. And hence bioaccumulation especially target the top predator of the food chain. Like in the ocean, we have the orca, killer whales, we have the shark, and in the river, we have the crocodile. Okay. But we as a human, actually, we cover everything. We are the top predator in the river, in the land, in the air, okay, and so on. Okay, so this is my current current work that we currently doing. So now this is some of the finding. So we determine the metal concentration in the organism. So we found that actually the shellfish organism have a higher concentration compared to the fish sample. Okay, so this is very I think all scientists, they have a quite similar finding, because shellfish actually is a phytopedes, and then when one pollutant nearby there, actually they cannot avoid. They have to filter all the pollutant. Okay, and from Malaysia, actually we found that some area in like Sungai Kelantan, Terengganu, or sort of Pahang. Okay, so we examine and the samples are still safe to be consumed. Okay, this is based on the calculation of the PTWI value. Okay, so this is our latest study. We study on organism. We focus on shark because we know that shark are the top predator in the ocean. Okay, and from this study, we divide into 5 parts: muscle, gills, stomach, liver, and also fin. So surprisingly, when we study it, actually we found that for the edible tissue, we found that the fin is higher compared to the muscle. So we are still looking why the fin is higher compared to the muscle. Okay, so but we can say when I have this data, actually we can make some conclusion. Okay, just share with you all. So in year 2022, so about 150 accident, okay, only 5 deaths of human, okay, by shark. But we actually estimated we kill about 100 million of shark every year, okay. And from our finding, actually, we found that since the fin is very high, so we can say that we have to stop shark finning and we stop consume of the shark fin and so on. Okay, so like we can make some poster or shark for the shark, fin for the shark, and then not for the soup and so on. Okay. Then our latest report study on organism, we studied the raw and also the cooked sample. So we eat the cooked sample. So I think it's more accurate that I analyze the sample in the cooked form. Okay. So only edible tissue will be analyzed to calculate for the human safety. And the cooked sample now we try to test it on mice and how much they intake the matter in their body. So this one we can have a quite accurate data because when the mice actually have a quite similar system with our human, so we can try to calculate how much the matter store in their body system and how much they remove from their body system. And this is one of my latest approach. We're using the artificial muscle. So this is a collaboration with the Education University of Hong Kong. So we plan to put this device as Terengganu River Estuary because this river is nearby our area. So easy for us to collect and easy for us to monitor. Okay, this is artificial muscle. They're using something resin to collect all the pollutant. Okay. So next planning. So we plan to do the accumulation in aquatic organism from fingerling size to marketable size. Mean that one organism, for example, like sea bass, for example, we start study from the fingerling to the marketable size to study the bioaccumulation process. Okay, and then also try to relate the climate change in the metals uptake. Okay, also impact of ocean acidification because now ocean acidification is one of the quite popular topic. Okay, to be discussed. Okay, and then what are the effect to the metal uptake? So all the data actually we are stored in the GIS database for the future analysis. So just a take-home message: we are not restoring to marine environment to normal condition, but actually we are create a new marine environment. So like when you ask me how we're to solve the pollution problem in the ocean, if my opinion is we say that I think what in the ocean, we just let in the ocean. But what we can do actually, we can reduce from the source. I think it's most important we reduce from the source. Okay. So for example, like you say, microplastic, how to remove? The most easier to remove microplastic is by using net, the plankton net. But when we store the plankton net, how about the plankton? So we also store together to the plankton. We know that plankton is very important. Okay. That's why for plastic, maybe we can reduce the source, not in the ocean. Okay. So together individually we are one drop, together we are ocean. So that's why we have to work together to solve something like the ocean mystery and so on. So we are looking for new research collaboration to explore the beauty of pollution study and to fill in the gap. Because I believe that my group actually is not cover all the not cover 100% of the pollutant, but maybe some of the friend or others researcher can help us to fill in the gap. So I think that's all. Thank you for me.
Dr. Ong, thank you very much for your great presentation, which gave us very important messages to do in near future. And I also believe that in your presentation, we got very nice information. And I believe that the participants will definitely contact you if they are interested in artificial muscles, climate change, and ocean acidification. And I also believe that you will also collaborate with them and probably they will be a collaboration issues with the international participants. So thank you very much once again for your very nice presentation and information. So as I mentioned, we will collect all questions using Zoom chat box. So if you have any question, you can write it down to Zoom chat box, and at the end of all presentations, we will ask them to the our distinguished speakers. So we can continue to second speaker, who is Ade Yamindago. Before his presentation, I would like to give you some information about his academic background. Dr. Ade Yamindago is currently working as a lecturer at the Marine Science Study Program, Universitas Brawijaya in Indonesia. He gets his doctoral degree in ocean science from the Korea Institute of Ocean Science and Technology, University of Science and Technology, Republic of Korea in 2020. He gets his double master degree in the field of aquatic science and aquaculture from Brafa University in Thailand and Universitas Brawijaya, Indonesia in 2013 and in 2012, respectively. He graduated bachelor degree in marine science from Universitas Hasanuddin, Indonesia in 2007. Dr. Ade is interested in investigating the effects of pharmaceuticals and personal care products in both vertebrate and invertebrate marine and freshwater organisms at cellular and molecular levels, which is generally known as toxicogenomics. This approach could give a comprehensive perspective about the effects of chemicals on the organisms. His work has been published in high-impact factor journals and significantly contributes to gain knowledge in the field of toxicology. In 2023, Dr. Ade was nominated as the third winner of the Best Lecturer with significant contribution in the field of science in University Brawijaya, and the second winner of the Best Head Bachelor Study Program at the same university in 2024. So, Dr. Ade Yamindago, floor is yours, and we are really looking forward to listening your presentation.
Okay, thank you very much, Professor Bulen. Good afternoon, everyone. I'm Ade Yamindago from Universitas Brawijaya. Let me share my knowledge and experiences in investigating the effect of pharmaceutical and personal care products on marine organisms. In this presentation, it will cover a brief introduction of pharmaceutical and personal care products, and also the volatile organic compounds that can be added in pharmaceutical, as well as the model organism used in toxicity evaluation, and example of toxicity evaluation in pharmaceuticals and on marine species. To give you a brief introduction of pharmaceutical and personal care products, it is not a main pollution at the moment, maybe, but however, it will start from our house. People use pharmaceutical, whether it's with prescription or non-prescribed drugs, and it will goes to the aquaculture as a runoff, and then it will goes also to wastewater treatment plants, and then it will go to the drinking water sources, and so on. And therefore, even though the concentration of pharmaceutical is not as high as heavy metals or other pollutants, but it will continuously emitted to the environment because of daily consumption of control or people with prescription or unprescribed drugs. At the moment, the concentration of pharmaceutical and personal care products range from nanogram per liter to microgram per liter, and some of them can reach to 1 milligram per liter. And some of the PPCPs detected in environments such as antibiotics, anti-inflammation, antibacterial, anti-consultant, and so on. Even though the concentration of the PPCP is still low, however, some of them are categorized as hazardous materials. Our previous investigation on volatile organic compounds, which is added in the pharmaceutical care products, mostly contain of phenol and some other chemicals. In the evaluation of the toxicity of the pharmaceutical and personal products, I use at least two model organisms because, for example, Orzias japonicus is native in peninsular Thailand, Malaysia, Singapore, and Indonesia. And based on investigation or evaluation of whether this kind of organism can be used as model organism, at least we can see here that the organism has a similar function with the human, so we can use this organism as alternative organism besides using the vertebrates such as mice. And this organism also is easily to catch or can be cultured in our laboratory. So, and then this organism can be the effect of pharmaceutical in the organism can be evaluated since they are still in embryo until they are adults. So this kind of organism is useful for several previous studies such as benzoapiran, heavy metal, estradiol, and nonylphenol. Mostly in this animal use male organism or male species, so it can evaluate the effect of chemicals such as estradiol as may have effect on endocrine disruption. The next model organism is Metella strigata. This organism can be found in Indonesia and most of the countries as easy to catch in the seashore. To give you a brief example of evaluation of PPCPs, previously we investigated the effect of fluoxetine in Orzias japonicus. This organism become a useful model for evaluation of toxicity in several chemicals. Why fluoxetine become important? Because recently the number of people with depression increased up to 280 million. It's about 3.8% of the population. And the depression is not only people adult or young also get depression. And by WHO, World Health Organization, suggested that fluoxetine is a recommended drug for treating depression, and therefore we investigated the effect of fluoxetine in fish. We evaluated the median lethal concentration, or LC50, of fluoxetine in fish. When in this research, I also added information from the hydra. It is Cnidaria, freshwater Cnidaria. The LC50 of the fluoxetine range from 1 ppm to 2 ppm. And we also evaluate the toxic effect of fluoxetine in fish by observing the effect of fluoxetine in swimming behavior. In light condition, it is shown that there is decrease in swimming performance in terms of velocity and in terms of speed and distance. In that condition, showing the same condition, that fluoxetine reduce the swimming performance, especially velocity and distance. Means that the effect can effect on distribution and also effect on the migration of the species as well as reproduction. They can difficult to find their partners to continue reproduction. We also evaluated the effect of fluoxetine at molecular level. First, we induce the species with a low concentration and high concentration, considering the concentration of fluoxetine found in environment. And we found that several genes upregulated and downregulated in terms of times. And by identification of biological process, we found that several genes associated with oxidative stress, DNA damage, cell death, protein damage, endoplasmic reticulum stress, and mRNA instability. And we also found that this chemical induced endocrine disruption, especially spermatogenesis, which is important for development of sperma. It will also affect on locomotory behavior, especially circadian rhythm. It will also affect the metabolic process as well as multicellular organism process, especially digestion, inflammation, and there is several genes associated with response to chemical, especially response to drug. So this kind of gene were identified respond to the effect of fluoxetine in Oryzias javanicus. In conclusion, this study found that fluoxetine induced lethal in Oryzias javanicus at relatively low concentration. Fluoxetine also reduced the swimming performance of Oryzias javanicus that may affect distribution and reproduction. Fluoxetine potentially induced oxidative stress, which could lead to mRNA instability and endoplasmic reticulum stress, behavioral changes, including poorer swimming behavior, swimming performance, endocrine disruption that potentially cause sexual and population imbalances. Therefore, it become a serious problem if the number of fluoxetine, concentration of fluoxetine increase in an environment. And next investigation, we investigate the effect of benzalkonium chloride, which is used as disinfectants and antiseptics in our households. Because also benzalkonium chloride is recommended as a cleaning agent, especially in the case of COVID several years ago. Several countries also suggested that benzalkonium become agent of cleaning for treating hard materials against the COVID-19. In Indonesia, benzalkonium chloride is added as agent for cleaning in the street, and also previously they used box added with benzalkonium chloride spray in the person. And even though benzalkonium is considered safe for human and applied in household, but we question the safeness of the benzalkonium chloride in environment, because we found that a previous study found that the concentration of benzalkonium chloride was estimated 200 to 300 microgram per liter, and it may increase during the application of benzalkonium as a cleaning agent. Previous study investigated that in fish, benzalkonium induced antioxidant enzyme and DNA damage in rainbow throat. And in another fish, benzalkonium reduced the hatching rate and increased mortality in zebrafish. Therefore, there is no information about the effect of benzalkonium in shellfish. And also the shellfish showed slow movement, means that if the benzalkonium or chemicals found in environments, organisms with slow movement will survive hardly than the fish. Also, no data of toxicity about benzalkonium chloride, and in shellfish, it is a high economic value and is also a raw material of traditional food. Our investigation showed that the median lethal concentration of benzalkonium chloride in shellfish Mitella strigata was 10 microliter per liter. And the median lethal concentration of other organisms in Cenobrobitis elegans about 3.1 milligram per liter, and in fish about 96 milligram per liter, means that the toxicity of the benzalkonium in Mitella strigata is high than other species. Our investigation on survival rate of benzalkonium in Mitella strigata also found that the concentration during the increase of concentration can reduce the survival rate. We also evaluated the sublethal effect of benzalkonium chloride. We found that at 1 microliter per liter, increase the movement, but however, at higher concentration, it decreased the movement, mean that increasing of movement at low concentration as indication of early life stress. In this case, we place the shellfish in the container, and then we measure the distance the shellfish go to one direction, and then we can evaluate the effect of benzalkonium chloride to the distance of the shellfish. And it possibly a new method to observe the behavioral effect of a chemical. We also investigate the effect on food and adductor muscle by using histological analysis. We found that there is increasing in gap in musculature and enlarged and fissure gap, as it is important for blood circulation, and it means it's possibly associated with decreasing in the movement of the shellfish. We also add transcriptomic analysis to evaluate which gene respond to benzalkonium chloride, and then we found that several genes associated with DNA damage, such as several processes, base excision repair, recombination double-strand breaks repair, and then mismatch repair. And this kind of term show that the benzalkonium chloride effect on DNA damage. It also affect on protein degradation, oxidative stress, and interestingly, we found that two genes associated with locomotion, means that if we evaluated the effect of benzalkonium, can be specifically use this kind of gene. Several genes associated with DNA damage, such as RSA1, IRAC, in NF2 or IT3, and so on. And then 1 milligram per liter benzalkonium chloride decreased the survival rate and induced DNA damage in rat hepatocyte. 0.1 milligram per liter benzalkonium chloride induced erythrocytic nuclear abnormalities and DNA damage. Means that our investigation add information about which gene are important for evaluation of DNA damage. We also found that several genes were associated with protein degradation, and then found that this kind of gene is important because it can be used as a marker for evaluation of pharmaceutical and personal products effect on organism. And several genes also associated with locomotor behavior, especially movement disorders, spontaneous locomotion, and explorative behavior, as well as motor learning and motor coordination. In this study, the behavioral observations show that benzalkonium chloride affects locomotor activity, also shown in the histological analysis, show that abnormality of feet and adductor muscle. As conclusion, benzalkonium chloride induced lethal and subtotal effect in Mitella strigata at relatively low concentration. Benzalkonium chloride also reduced and stimulated motoric activity at specific concentration, increase at low concentration and decrease at high concentration. And it may associated with abnormal anatomy of foot and adductor muscle in Mitella strigata. And by transcriptomic analysis, we found that benzalkonium chloride changes regulation of gene associated with the DNA damage, protein degradation, oxidative stress, and locomotor activity. So by using transcriptomic analysis, we found a comprehensive information associated with what we observe at lethal and sublethal toxicity evaluation. That's all my presentation. Thank you very much for your attention.
Dr. Ade Yamindago, thank you very much for your very nice presentation. In your presentation, we got very nice information about your research results on BZK in fish species, pharmaceutical and personal care products on marine science organisms. I believe that the researchers, master and PhD students at Inter-Islamic Network on Oceanography will contact you in case if they are interested in this field. So once again, thank you very much for your very nice and informative presentation. So before the third speaker, I would like to inform once again that if you have any question, you can directly write to Zoom chat box. At the end of all presentations, we will ask them to our distinguished speakers. So we can go to third presentation, but before going to listening Dr. Naim Abbasi, I would like to give you a short information about his academic background. Dr. Naim Abbasi is working as an assistant professor in environmental toxicology at the College of Earth and Environmental Sciences, University of the Punjab, Lahore, Pakistan. Dr. Abbasi is an environmental toxicologist with his expertise in assessing the level of heavy metals and organic pollutants in different species of birds in Pakistan. He has 6-year teaching experience of different subjects related to ecology, environment, and conservation. He has published more than 30 research articles in journals and 3 book chapters. So far, he has supervised 12 masters and 1 PhD thesis. Currently, Dr. Abbasi is investigating the level of emerging organic pollutants in birds of Pakistan and their effects. This assessment will be replicated with seabird species in future. So, Dr. Naim Abbasi, floor is yours for your presentation, and we are really interested in listening your presentation. Thank you.
Hello, everyone. Hello, everyone. Thank you very much. And let me share my screen first. So, this is my presentation topic. It is exposure and effect of classical and emerging organic pollutant in top predatory birds of Pakistan. So, basically, as mentioned in the previous presentations, that monitoring is very important, and monitoring the environmental pollutant is very important. And for that, selection of species are very important, because only best monitoring evidence can be provided if we have best selection of species. So, what kind of the kind of pollutant I have selected for my presentation today is the organic contaminants. And organic contaminants, briefly, they are about organic contaminant is that they are persistent to environment. They are lipophilic, mean they are fat living, and they are hydrophobic, and they have wide range of distribution because of their usage in the environment, like pesticides, flame retardants, and many more. So this is what has been explained earlier, the bioaccumulation and biomagnification. This is where the problem lies, because with passage of time, these compounds bioaccumulate in the living organism and then biomagnify through the food chain and then become a cause of concern, particularly for the predator species. They are toxic to human and wildlife because their constant exposure can make health effects, can create various health effects in human and wildlife. So they are the concerning chemical. The most concerning families of organic contaminants which are regulated through Stockholm Convention or called persistent organic pollutant. So everyone might have known that the Stockholm Convention is the global convention which deals with the regulation of Stockholm with the regulation of persistent organic pollutant. So legacy, so we normally divide the organic pollutant into two major types. The legacy one, legacy pops which have been used since long, and the emerging organic pollutant which are used which are novel and which are not used since long, but they are introduced in the environment recently. So this is the website chm.pops.int, where you can see the detail of this is actually website for Stockholm Convention, where these organic contaminants are and their regulations are actually provided. So getting started, actually we have reviewed the presence of organic organohalogen contaminants in Asian bird species years ago, and we found that there is a lack of data reported in birds of Asia, particularly from Asian part. So in that review, what we have found that commonly these legacy POPs, PCBs, PBDs, coplanar PCBs, DDTs, HCH, and these are reported. And in emerging, some of the flame retardants, they were reported as emerging pollutant, like HBCD, DBD. These are the classes of emerging pollutant. So 56% were of legacy POPs, and 44% studies were of emerging pops. So this is what our review paper shows, that the concentration is high in East Asian countries, for example, in China and in Japan, where industrialization is high, and as expected, the agriculture input and industrial input and urban input is much higher. So the concentration of PCBs and DDTs is higher. Whereas you can see in Southeast Asian part, India and Pakistan, very few studies are reported. And in case of West Asia, very few, almost no study, just one study from Iran and one from Turkey is reported. Maybe some of the studies has now been added. So lack of data in this region. Similarly, for PBDEs, we found that the studies, the concentration is elevated in China and in other part of the East Asia. But in case of Southeast Asia and West Asia, the data is reported is very less. So what we found that mostly in East Asia, the mostly industrialized countries are present, and high concentration of organohalogens contaminants were reported. In Southeast Asia, most of the developing world most of the countries are developing, higher agriculture input, but studies are reported. Very few studies were reported. In West Asia, mostly developed and developing, but no data is reported. So transboundary movement of organohalogen is also one of the concern. So here in this map, we have shown the, what we have found, that in East Asia, the concentration were high. In Southeast Asia, it is moderately high, but in Middle East and in this part of the Asia, the data is not reported regarding birds. So we found these data gaps. Predatory birds species has been least emphasized in Asia. Temporal trends of the contaminant is altogether missing. A huge gap for reported regional contamination level. Factor influencing organohalogen level has not been elucidated. Novel brominated flame retardants has not been focused. Non-invasive biomonitoring study tools have been has not been elucidated, and implications of these organohalogens exposure to birds has not been reported. So these were our problem statement, that industrial and urban exposure in developing countries like Pakistan is adding a surplus of legacy and emerging contaminants in the environment. Bioaccumulation and subsequent biomagnification of organohalogen might be a serious threat to the already declining predatory avifauna of Pakistan, and also the factor influencing the level of organohalogens in birds. So I will briefly explain the results, what we have done in the past and what we are currently doing and what we are planning to do in the future. So our objectives were clear. First, we have to monitor the level of some of the legacy and some of the emerging. We have selected, keeping in view the condition, the environmental exposure in Pakistan. So level of legacy and emerging contaminants. Trophodynamics mean the level of trophic level and its association with organic contaminants, so stable isotopes. Factor influencing the contaminants level, and effects of these contaminants through oxidative stress response, for example, the enzymatic activity and also the mRNA expression. So briefly, we have collected, so we have selected these sites from Pakistan, and we have collected these species. These are almost 9 species from 13 different sites of Pakistan. But in the one thing I want to mention, which I mentioned in the introduction section, that we have collected the blood and feathers, which are normally called as minimally invasive matrices in birds, because these predatory species, they are already declining, their population is declining, so we can't kill or sacrifice the birds, but we focused on the use of feathers and blood and sometimes preen oil, which we are currently using. as a minimally invasive parameters or the matrices which we can use through which we can monitor the bird species. Otherwise, killing the bird or sacrificing the bird is facing certain ethical and scientific concerns. So these are some of the species. Kestrel, these are predatory species actually. Owls, this is redneck falcon, cormorant, herons, and this is vultures. These are vultures. So these two species. So chemical analysis, what we did is we have analyzed these legacy PCBs, PBDs, DDTs, HCBs, cis and trans nanochlor and oxychloroden, and HBCDD and BTB. These are the compounds which are novel compounds. So these are the compound quantified in blood, and almost similar compounds quantified in feathers. So after cleanup and extraction, we have quantified the organic contaminant. To see what is happening as a result of exposure of these organic pollutant in birds, we have carried out the enzymatic activity for GPX, GST, GR, and catalase. These are the enzymes through which we can, measure the activity of antioxidant enzyme and correlated it with the concentration which we found in feathers and blood. And also expression of genes were also investigated. We have also investigated the stable isotopes to determine to actually correlate the concentration with the trophic levels of bird species and dietary sources of the through carbon, actually through carbon, stable isotope of carbons. So I will discuss briefly some of the results which we found. As you can see that in Pakistan, the DDT and DDE, which is the metabolite of DDT actually, is found in high concentration, and you can see some of the fluctuating detection frequencies for PCBs as well. In this graph, you can see that the concentration of DDE, which is a metabolite of DDT, is the highest, found in highest level, followed by DDT, and then penta-CBs, hexa-CBs, and hepta-CBs. These are the different classes of PCBs which we have found, which we targeted for the analysis in these species. So here you can see only I have plotted CBs. So you can see that hexa and hepta CBs, which are the more persistent classes, are more prevalent in feathers of different bird species from Pakistan. And here you can see where we have only plotted the DDT and DDE. So the para DDE, which is a metabolite of DDT and DDT, these two are reported in high concentrations. So in this graph, actually, we have shown that how trophic level is associated with different species. We have plotted, you can see here on the x-axis, the y-axis, the level of nitrogen stable isotope, and on the x-axis, the carbon stable isotope. Carbon stable isotope, carbon-13, actually tells us about the dietary sources in the habitat, whereas nitrogen tells us about the trophic level of the species, trophic level of the species, so that we can correlate it with the exposure level. So you can see that some of the species like kites and most of the species, because all of them were predatory species, so most of them lies in the similar region. However, some of the species like a cormorant, because they are piscivorous, and some herons, they are aquatic predator, and they are specialized predator on fish. That's why they are lying somewhere above on the graph, showing that they have some higher trophic level compared to the terrestrial species. So this is interspecific comparison. Here we have shown that how trophic level is associated with PCB's level, and you can see that we have found some significant positive association of trophic level with the PCB's concentration when we have plotted it against the log normalized PCB's concentration with nitrogen stable isotope. Similarly, you can see the DDTs. Although you can see in the previous graph as well as in this graph that no very significant relationship between the trophic level and DDTs has not been found. But we can see that some of the moderately significant result showing the association of trophic level with DDTs. Similarly, for HCB, this is a legacy compound. So this is for that HCB. Again, no significant correlation. So one thing we have also studied in one of our study that how different feathers type is related. So you can see body feathers, tail feather, primary and secondary feather we have taken for these contaminants analysis. And we found that PCBs and DDTs and trans-nanochlor TN is actually significantly varied between body, tail, primary, and secondary feather. So this is because the origin of the feather, the molting pattern, and the type of species which we are considering is actually important in this case. So here is the detection frequencies for BFRs, which is again, I don't go in the detail because this is fluctuating. And you can see that BDEs, polybrominated diphenyl ethers, these are the compounds which are being used since long, or the dominating class in this in feather of these species. And here you can see when we have plotted this PBDs are the dominant class, then followed by HBCD. HBCD is actually a novel compound, which is a flame retardant, but has not been used since long. So here you can see different classes of PCBs. PCBs 47 is the most dominant, followed by PCBs 99, and then PCBs 153. The punchline, the basic thing is that the most persistent the compound is and the most longer time it has been used since, it is reported in high concentrations. So this is for HBCDD. It is again alpha, beta, and gamma, and you can see alpha, which is more consistent compound and more persistent, is reported in high concentration compared to gamma, whereas beta is reported in less concentration. So this is for reflecting the association of stable isotopes of nitrogen, which is reflecting the level of trophic level of species with PBDEs. Again, you can see there is no significant, strikingly significant difference, but there are significant relationship of these compounds with trophic level. Again, with HBCDs, you can see some of the associations which are significant. So the interestingly, this is not significantly the level of novel brominated flame retardant like PBDEs and HBCDs and BB, they are not significantly different among different feathers types. So these are we have selected two species actually when we have blood and feathers, both we have collected from that species. So black kite and spotted owlet, and this is the detection frequency. You can see the detection frequency of black kite is high, and similarly in this case. So here you can see the concentration, and the concentration is relatively higher in spotted owlet, but in some compounds are higher in black kite. This is because black kite is more urban species, and it is a generic opportunist species, whereas spotted owlet is much more specialized. So this is the concentration of persistent organic pollutants reported in blood, and you can see the concentration of different compounds, which is again higher in spotted owlet because of its feeding habit, which is specialized. So I have not shown all the results, but some of the results which were significant I have presented here, that how the exposure of FOP is actually affecting the enzyme activity. So what we have found is the association of this you can see the association of these compounds with the GST level, that is a antioxidant enzyme actually. So a significant correlation, positive correlation with these compounds has been reported. Similarly, for PBDs, you can see that GR, which is again oxidative stress enzyme, is reported with significant correlation with blood of spotted owlet. Similarly, you can see the BDE 100 has shown significantly high correlation with catalase activity in feathers of spotted owlet, and also you can see feather of spotted owlet, the GR activity is significantly associated with concentration of BDE 100. So these are the significant results which we have shown. Now you can see the gene expression level, which we have studied in some of the cases. So in this case, you can see that in blood of spotted owlet, it is negatively associated with SOD's copies, and with in case of feather, the level is positively associated. It is positively associated with genetic expression of actually these enzymes. So the key discussions from today's presentation is that the DDT and PCBs are reported considerably higher than reported in European Union or USA. Hexa and hepta CBs were prevalent in terrestrial, while penta CBs were so in aquatic species. Trophic level, taxonomic affiliation, and dietary proxies best explain the results of PCBs and OCPs. In general, PCBs and OCPs varied significantly among different feathers type, but not PBDs and other compounds, interestingly. So concentration of BFRs were comparable or lower than reported elsewhere. BD 47 in aquatic species and BD 99 and 153 in terrestrial species, and alpha HBCD in general were the most prevalent compound. Species, trophic level, and level of nitrogen were found as the major predictor of BFR concentration. So variation of BFR's level among feathers type were non-significant. So you can see we have found some significant correlations between the level of different oxidative stress enzyme as well as the gene expression levels. So this reflects that there is some correlation exists between the level of different organic contaminants and enzymatic activity as well as genetic expression. So cause-based effect studies are needed to develop the threshold of these compounds, that at which threshold these can be dangerous to the species. So take-home message for today's presentation is that level of organic contaminants are rising, which may threaten the already declining predatory bird species of Pakistan, but not only for Pakistan, but in Southeast Asia. Organic contaminants can initiate oxidative stress response in birds, which is poorly understood, and there should be studies in future that how organic contaminants are causing the affecting the oxidative stress, and formulation of proper regulation of OC's release and its regulation is really needed to actually avoid the population decline of predatory species, which is already declined globally. So this is the for my presentation, and actually I am really thankful to the Inter-Islamic network on oceanography for providing me this opportunity to present some of my research which I have done. Currently, we are actually interested in assessing the level of, we are working on different species of birds, and we are investigating and measuring the level of different novel novel compounds like, for example, PFAS, PCNs, and SCCPs, chlorinated paraffin, which are reported in elevated concentration. So we really wish that we can collaborate with the through this network. We can collaborate with some of the different universities, and I am really interested to see these kind of effects and these kind of contaminants exposure assessment in the seabird species of the Malaysia as well, for which I am already in touch with Dr. Naima, who is my ex-colleague in Quaid-e-Azam University. So thank you very much, and I'll be happy to answer the questions at the end of the session.
Dear Dr. Naim Abbasi, thank you very much for your very nice presentation. In your presentation, you provided us up-to-date information about data gaps, specific chemical analysis, ecology, environment, and conservation in bird species in Pakistan. As you said, actually, you created a great opportunity for INOC researchers, master and PhD students, for them to communicate with you if they are interested in bird species in not only in Pakistan but also in their countries. I believe that INOC network will definitely increase with this kind of opportunities. So for that reason, thank you very, very much once again for your very nice information and presentation. I would like to repeat once again that we will receive your questions in the Zoom chat box. So if you have, I see that Asad is hands is there, but we will collect all questions in Zoom chat box. So if you have any question, please write it down to Zoom chat box. We will ask them to all questions at the end of symposium. So I would like to invite the last and final speaker, who is Dr. Naima Hamid. We are also really looking forward to hearing Dr. Naima presentation. But before her presentation, I would like to give you some short information about her academic background. Dr. Naima Hamid is serving as a lecturer in the Marine Science program at the University of Malaysia, Terengganu. She is actively involved in community and knowledge transfer programs, mentoring undergraduate students, and is a part of ocean pollution and ecotoxicology research group at UMT. Between 2021 and 2022, she served as an assistant professor in the Department of Environmental Sciences at Lahore College for Women, University, Pakistan. Her research interests primarily focus on ecotoxicology and health risk assessment of hazardous chemicals in environmental matrices. She holds the position of early career editorial board member for 2 international journals, namely Science of the Total Environment and Journal of Hazardous Materials. Dr. Hamid received her doctoral degree from the University of Chinese Academy of Sciences, China. Dr. Hamid has authored or co-authored 2 books published by Springer Nature Publishers and Bantam Science Publishers. She has contributed significantly to her field with around 45 research articles and book chapters published in high impact factor journals. So, floor is yours, Hamid, Dr. Naima, and we are really looking forward to listening you. Thank you.
Thank you. Thank you. Okay. Good morning and good evening. dear fellows and colleagues. So today my topic of presentation is effects of organic pollutants on freshwater species. And the contents of my presentation are background, POPs, global distribution, the toxicity effects of legacy and emerging POPs, bioaccumulation, biomagnification, toxicological effects on freshwater species, integrated ecotoxicological assessment, and toxicity testing in 21st century, and my future research outlook. Okay, so as previously stated, what are POPs? So you guys know very well, POPs are basically the organic substances that are persistent in the environment and accumulate in living organisms and pose a significant health risks to the environment. Based on their chemical composition, they are persistent, bioaccumulative, and toxic in nature. So we can call it at PBT in nature. And they are difficult to biodegrade and widely distributed in different environmental matrices. And if we look in terms of its chemical structure, so they are difficult to biodegrade. And according to Stockholm Convention, started from 2004, 12 initial POPs were included in this convention. As Dr. Naeem previously said, that this is the convention held in Stockholm and required for the regulations of the POPs using worldwide. And in 2000, in terms of its historical background, in 2009, 9 POPs categories of the classes of pollutants included in Stockholm Convention, and from 2009 to 2017, 7 POPs more were included. So total, if we look in terms of its origin, so blue color one shows that these belongs to pesticides. And the red triangle shape one shows these are from industrial byproducts. And the orange one showing they are produced as a result of the combustion activities. So total, we have a large groups of chemical compounds, or if you can call it such chemical groups of the POPs. So now today I'm talking about on PFAS. So before that, let's have a quick review how POPs enter in the environment. What are the fate? So based on the sources of POPs, we have some natural and anthropogenic sources, and from the industries, from agriculture, through personal care products. They enter in the environment through air in the form of long-range atmospheric transport, and through rain. It can be infiltrate and seep down and enter into our groundwater ecosystem and disturb the groundwater quality. And through runoff can enter into the rivers and ultimately enter into the oceans. So when enter in the oceans, or they can easily bioaccumulate and biomagnify and can cause health effects. So again, the general classes includes pesticides, PFAS, PCBs, PBDs, flame retardants, OCPs. These are basically different compounds of the POPs included in that. Okay, so now in terms of its detection techniques, how POPs can be detected in the environment. So around majority, 90 to 95% classes of POPs can be detected through GCMS analysis. Some of them can be detected via HPLC-MS or HPLC-MS-MS, and there are some other methods which we can detect POPs, such as electrochemical bioassays, through infrared Raman spectroscopy and some colorimetric analysis. But majority, if we say that through GCMS or through HPLC-MS, we can able to quantify POPs in different environmental matrices or biota. So in my presentation today, I will be focused about PFAS. So let's look about its global distribution of PFAS in surface water. So in PFAS, we have a large groups of chemical containers or chemical classes included in this group. So these also have some legacy and emerging PFAS. So legacy PFAS, we can say PFOA and PFOS belongs to legacy PFAS, and the rest of the compounds are emerging or PFAS, you can say. So if we look in terms of its distribution, so the highest level of PFAS were reported in US, China, and Australia. And if we say that in terms of in Asia, relatively less studies have been reported. And if I talk about in Malaysia, only one study have been reported till now about the PFAS level in surface water. Okay, so now what about the ecological health risks? So if we see in terms of its ecological health risks, so we can say that these countries have some carcinogenic risk and some countries have non-carcinogenic risk. So I have compiled the studies from throughout the world about PFAS, and then I have computed the health risk assessment using two bioindicator species or the freshwater species. One is Denio ridio, is the zebrafish, another one is Daphnia magna. Both are freshwater species. So you can see different color gradient over here. So if the value is less than 1, so it means that these two species doesn't have any significant health risks. Or if its values is increased above than 1 to 1,000, it means that it's increased from considerable risk to the high risk. So as we see PFOA and PFOS among all the countries, they have high significant risk because that's why they are considered as a more carcinogenic compounds of PFAS, both in zebrafish and in Daphnia magna. Okay, so what are the basic routes of exposure to these chemicals? The basic routes are ingestion through thermal contact and through inhalation. These POPs enter into the ecosystem. If we talk specifically in terms of marine ecosystems, so through bioplankton, through zooplanktons, they can enter into the small fish, and through tropical transfer, enter into the large predators. Okay, so as again, the same concept, when the chemicals enter or in contact with any organisms, so they immediately bioaccumulate, enter into their cell walls, and they biomagnify when they go up to the trophic levels. And its concentration will go up to 10-fold. Okay, so there are different kinds of organisms that are used in the studies as model species. So most of them that are widely used are bacteria, algae, oysters, mussels, fish, water fleas, and plants. So what I'm using indicator species of Daphnia magna and zebrafish to study the toxicological effects of these POPs in many freshwater species. So let's see what happens when any organism, any pollutant in contact with biological species, first based on their chemical composition and their reaction with their organic and inorganic molecules of the organism, as well as the organic species of the organic chemical speciation of specific compounds. They enter into the cell membrane and enter into the body. If it's like a species is very you can say that it's new, or it's like egg starting from their life cycle. So we can call it as we can observe its developmental toxicity. And in terms of when it grows, so we can say that we can observe its toxicity in terms of its histological alterations, tissue, and then in terms of its body distribution, and what are the mode of actions and how they transfer into the food web. So there is a concept, we call it as adverse outcome pathway concept. So adverse outcome pathway concept is basically identified the cellular and molecular events of any chemical required to produce a toxic effects when any organism will exposed to a certain chemical. Let's suppose the level of the biological organism starting from a molecular level to a cellular level, we will observe as a developmental toxicity. And then as the organisms grows, species grows, so we can check its toxicity up to the tissue level, the specific organ level, and how these toxicity ultimately affects the survivability of an organism. So we can say that from sublethal to lethal, we can say that we have some primary toxicity endpoints and we have some secondary toxicity endpoints. So this is a study reported about the PFAS levels in different marine species: mussels, snails, worms, sediments, and waters. So PFAS can also be categorized based on their molecular weight. Some have short chain PFAS, PFBA, PFEA. These are some chemical congeners of the PFAS, and some are long chain PFAS. So we can see that in water, most of the chemical composition up to around 50 to 55% belongs to short chain PFAS. Whereas if we see in terms of the sediments, there are worms, snails, and mussels distribution. So long chain PFAS have showed more than 100, like 90 to 100%, they have their contribution. Okay. So this is the now coming towards the PFAS toxicity in freshwater species. Based on the environmental levels, we have done this experiment in the lab. So we have mimicked the concentration of PFOA using environmental level exposure into low dose and high dose. The low dose is like 10 microgram ml per ml, and high dose up to 20 microgram ml. So main motive is like how if a chemical to mimic the real environmental conditions in the lab. So when we exposed these concentrations to Daphnia magna, which is bioindicator freshwater species, for about 7 days, we found that from day one, like for 0 HPF, we call it as post-fertilization as the new organism, the baby one. We exposed them up to 7 days. So every day we calculated their heart rate, their mortality, body weight. So we found a significant developmental toxicity effects in terms of its like tail, like the missing tail, the missing antenna, the eyes deformation, the body, the carapace were swollen, and we found some blood clots inside the body. And then after, to confirm their toxicity, we performed the apoptosis assays, which is basically the DNA damage. So now we are moving from developmental toxicity towards the cells or the gene level. So you can see from in A figure, from AB to ED, the white color arrow shows the green dotted points. The green dotted points means that these regions have a DNA damage. And we compare these fluorescence value from control to low dose to high dose. From high dose, the fluorescence value increased up to 350. So we can conclude that the higher chemical dosage, even though it's very small in the environment, they can cause DNA damage to Daphnia magna. Similarly, we exposed PFOS to zebrafish, and for 10 days we exposed zebrafish from 0 to like 7 days, which is called as acute toxicity time period. And we found that their body tail was deformed, and their size of the growth size or the length, body weight also decreased compared to the control treatment group, as well as the body weight will also be reduced. Or similarly with the apoptosis, we have found the apoptosis in the liver area. And to confirm these, some of the tissues staining results, these are the histological results of both male and female fish, found the both male and female fish shows significant toxic effects compared to the DMSO are the control group, both in male and female ones. Their hepatovacuolar cells of the tissues were not common, but not a normal range. You can see in terms of from the control group to the exposed ones, their tissues are distorted. And this one is on the D figure, these are the gut cells. So gut cells of both female fish and the male fish. In the gut cells, we have like vacuolar cells area of which are major significantly reduced compared to the control group, both male fish and the female fish. So in conclusion, we can say that PFOS, even though environmental relevant exposure, very low dose concentration, about 16 micromolar or 32 micromolar, can cause a significant genetic toxicity effects to zebrafish. Okay, so now I'm going to introduce a new concept, which is integrated ecotoxicological assessment. It means that we can use the real environmental data and do the experimental toxicology work using in vitro models, using in vivo models and clinical studies, and to confirm these toxicity results using computational toxicity. We can call it as in silico models to draw a ecotoxicological assessment, whether this chemical is safe or not safe. So This is a recent latest toxicity concept. Is toxicity testing is 21st century talks 21. US EPA introduced this concept in order to decrease the animal usage for toxicity testing instead of using the high throughput screening techniques. The aims of the talks 21 is basically to identify the toxicity, develop the models for toxicity prediction. It can reduce the testing time, effort, and the cost, as well as give the more precision and accurate results in terms of prioritizing the chemicals in terms of the toxicity effect. So there are different predictive models have been using, different omics techniques have been used. So some of the predictive models, they have like structural based models, based on the dose response, time response models. They have some pharmacokinetic and pharmacodynamic models, quantitative structure activity relationship models, and some of the models are machine learning or artificial intelligence models. In US CPA websites, there are lots of predictive models freely available that have been used, that I also have been used. So it's good to shift towards the toxicity testing using the predictive modeling techniques. So the one model which I have used is quantitative structure activity relationship model using molecular docking software. So in that model, the concept is like this A figure 1. These are basically, I have calculated is for the CAT and GST enzyme, antioxidant enzymes for PFOA chemical. So this is the chemical 3D structure we have, and these are for the CAT and GST receptor proteins for the Daphnia magna. And they combine towards the chemical bonding. They basically simulate what are the exact binding amino acid sites of a chemical when they in contact with any organisms. So based on these values, we can found that the interacting amino acid residues for both CAT and GST are 8 and 12 binding sites. And the more docking score is the docking energy values. The more less the docking score value, it means they have a strong binding capacity. So in conclusion, I can say that using the eco-integrated toxicological approach, we can give the more precision results, and using the TOX21 techniques, we can minimize the animal sacrificing and to give the more accurate toxicity confirmation of the chemical that can be further used in regulations. And for the research future outlook, different legacy and PFAS chemicals, still they didn't have tests. We don't know their toxicity potential. They are abundant, they are prevalent in the environment. Even at low concentration in the environment can cause harmful effects to the marine species as well as the freshwater species. So different multi-model or different trophic levels studies should be conducted using the eco-toxicological assessments, which basically involve integrating knowledge from genomics, computational biology, metabolomics, and these are pretty much my future research outlook to prioritize the chemicals using the eco-toxicological assessment approach. So that's all from my side. Thank you.
Thank you very much for your very nice presentation and information you provided us. In your presentation, we learned that very nice and informative and innovative information about persistent organic pollutants, bioaccumulation, ecotoxicological assessment, and it was very nice to learn that your future research challenges. So thank you very much once again for your presentation.
Thank you.
So we came to questions and answers section. Unfortunately, we haven't received any questions at Zoom chat box, so it is time for us to get your questions if you have. Naima, may I ask you to close your presentation? Stop sharing your presentation so that we can see each other. Yes, thank you very much. So I think Assad was here, our INOC executive committee member. If maybe I can make him a co-author. So, Asad, do you have any questions? If you have any question on or contribution, yeah, I opened your microphone so you can easily speak to us. When he is opening his microphone, maybe I can give.
Yeah, thank you. Thank
Yeah,
you.
okay.
Thank you. Hi.
Hi.
Good evening, everybody. It's glad to see the nice presentation that we have. And I have questions regarding Dr. Naeem presentation regarding the concentration. What I have seen is that the number of the samples taken, especially for the bird, the number is especially regarding the when taken from the blood. It's a very low. I mean, comparing the results, I see very few samples. That's one question. Is that could you explain on that? Maybe elaborate on it. Also, I have another questions regarding the sampling techniques. I mean, how is the samplings being taken out? And the also the number of as I said, the number of samples is very kind of low. Does it any reason for that?
May I answer?
Yes, of course.
Yeah.
Actually, like in the beginning of my presentation, I have told that because birds are already declining, and particularly I have selected the top predatory birds, which are very few in numbers in the environment. So what we have to do is we have to choose the tissue which is minimally invasive. I mean, we can't sacrifice the bird, we can't kill the bird for the sake of, toxicity assessment. So what we normally do is we use those tissues which gives minimum invasions or minimum problems to the birds. For example, we take feathers, we take some blood if available, and we currently we are using the preen oil. It's oil under the tail of bird species which birds normally use for smearing. So in case, yes, I agree that this sample size is not as much as it should be. It's always the sample size is always a bigger concern. But it was in my case it was we have chosen the feathers for enough sample size from enough birds so that we can remove the maximum of statistical bias. In case of blood, yes, it was very low because the free-ranging bird species was not available for us to capture and collect the bird and then release them back in the environment. So that's why, but we have tried our best to to eradicate or to marginalize the problem of statistical bias. That's how I can answer your question.
Okay. Just for in your statements in the last statement, the concentration you mentioned, the concentration is higher than the other type of studies is being carried out, like the European one. Now the question is that I mean, how significant is? I mean, yes, it could be a little bit higher, but I mean, statistically, how statistically is significant?
Well,
I didn't see any comparison regarding this.
yes, actually, that the graph I have shown is actually from my review paper, in which we reviewed the published studies from the whole world, and then we compare that what is reported from where and how much is reported from which part of the world. So what we found is that the China and this part of the world, has the highest concentrations, followed by, but our concentration, and which we reported in birds, is almost similar or somewhat, near to those reported in, in European countries or in US. And the reason for this is that the DDT, especially the old pesticide, is being used in has been used in Europe and US since long, but they have banned it in 1970s, since 1970s. But although we have in our part of the world, the South Asian region, it is also banned in around 2000. But because you may know that India and African part of the world has provision for using DDT because of malarial control. So because DDT is still used in this part of the world, although it's not used directly in Pakistan, but it is maybe used illegally somewhere because India is our neighbor country. So that's why the concentration of some of the old pesticides are still, found in high concentration compared to the neighboring world, compared to European situation.
Okay, but I mean, how when you say it's a higher, I mean, how high it is? I mean, it has to have some kind of a touchable the numbers in order to say, okay, this is a very high compared to that. I mean, this has to be specifically that's what I mean. I mean, putting the general statement, it's a higher. Maybe to me, when I look at the statistical, the number that you are saying comparing to the statistical analysis, it's not going to be that much significant.
Yes, I agree. It's not much higher, but I have just given this. You can say you have used yourself the word generic statement. For generally, what we found is that our concentration. The reason I have told you that some of the pesticide which have been banned in Europe since 1970s, in South Asia, in our part of the world, they are still in use, either legally or illegally. So, but in case of, emerging pollutants, what I think is that the European level is much higher because they are using it in high concentration because they are much industrialized compared to us. So this is kind of comparison which I have drawn with the European scenario.
Well, actually, it would be a very nice. I see it's a very nice study. It would be very nice if it's do some kind of a comparison, maybe a table that's putting all this values from like the European, the found in India, and then you emerge your data in and stating on that as well. That's what
it should be graphical. Yeah, I agree.
So
Thank
I
you.
think that's all from Assad. The question is answered. So I haven't received any other questions from Zoom chat box. If you have any question, I would like to ask all participants if they have any questions. It is time to ask to our speakers.
If you allow me, I mean, since we are here and everybody is hearing us, it's just to maybe as an announcement that we are opening for the graduate students for all the Islamic countries. So if you have people who are interested to study the master degree, I think they could contact us. And I think this is something I mentioned to you while we are in Izmir. So I think so far we have not received any kind of inputs regarding this. So maybe it's a good idea to reestablish the ideas of spreading the word that such a scholarship is available.
Yeah. So thank you very much, Asad, for very nice information.
Thank you.
So I would like to thank all our speakers for their insightful contribution and engaging discussions during today's symposium on living sensor monitoring pollution in the environment symposium. As you know, together we explored the innovative technologies and approaches that are shaping the future of environmental monitoring. As we move forward, let's continue to collaborate. This is the one of the aim to organizing this kind of events from INOC. And please apply these advancements to create a healthier and more sustainable world. So, as you know, this is an online event. Unfortunately, we cannot give the certificate to our distinguished speakers to their hand, but let me share my screen about their certificate. So I would like to thank Dr. Ong Meng Chuan for his presentation. I would like to thank Dr. Naim Abbasi. I would like to thank Dr. Naima Hamid, and I would like to thank Dr. Ade Yamindago on behalf of Inter-Islamic Network on Oceanography. So your certificates will definitely be sent to your email addresses, and I would like to once again thank for your contribution to Inter-Islamic Network on Oceanography. So as INOC, we are committed to organizing more of these important series of events to drive progress in our shared goals. To stay informed and engaged, please don't forget to visit INOC, Inter-Islamic Network on Oceanography website and social media accounts for the latest updates. Of course, your participation is vital to this mission, and I look forward to seeing how these ideas will grow and flourish in the coming months. So thank you once again for all participants and our distinguished guests. Let's keep the momentum going. So this is final word from me as moderator, and before closing this event, I would like to thank President of Inter-Islamic Network on Oceanography. Without her help and support, it is almost impossible to organize this kind of symposium. So I would like to once again our distinguished speakers and their institutions to make this Inter-Islamic Network on Oceanography event happen. So I would like to say goodbye from Turkey, and I wish to meet in near future. Thank you once again.
Thank you.
So goodbye.
Goodbye. Thank you.
Thank you.
Thank you.
Thank you, Buran.
Bye.